Oh, you can hear me. I can hear myself, that means you should hear me. So, it's a great pleasure to present BloXroute Labs here in Berlin. And so in my previous life I was a professor of computer science at Northwestern University. Now I'm 100% with our startup. So I will tell you in short what we do and how we do it and what is the problem that we are solving. So, long story short, the problem we are trying to solve with blockchains is scalability. Okay? What it means is, despite all the buzz and despite all the great work and great white papers and research papers, the reality of blockchains is that Bitcoin today still has just 3 transactions per second, and Ethereum has 10 transactions per second, and to do anything in the real world, we really do need more scalability. Okay? I'll just give you a few examples. So, of course, the big example are the credit cards. We need, like, for example, Visa is supporting 5,000 transactions per second. And I'll just give you a few other examples. Consider the number of cars in the US and assume each of them will fill their tank once a week. And so just for that, you're going to need 450 transactions per second. Okay? If you just take the number of vending machines and assume each is used just 4 times a day, only for that you're going to need 1,000 transactions per second. And it is a little bit embarrassing to talk about all these crazy futuristic scenarios like, hey, machine-to-machine communications. Oftentimes when we talk about blockchains, people think of like, oh, there's going to be some super cool micropayments and applications, and it's a little bit embarrassing to talk about all of these cool applications when the reality is at a completely different stage. So what we are trying to do at BloXroute is we are not a blockchain ourselves. We are a project that tries to help all other blockchains to scale. Okay? So our mission is to say that no single blockchain should fail because they can't scale. We can help you scale, but your job then is to bring in traffic to make your blockchain useful to the rest of the world and so on. How are we doing this? Well, we call ourselves a layer 0 solution. Okay? Layer 0, which means that we are a networking solution that helps scale every single blockchain out there. So, to move on, let me quickly, let's start from scratch. Okay? I know that this is a very technical community, and I know you guys know all this stuff, but even if there is one person here that doesn't know about this, it's worth going back to the basics. Okay? In Bitcoin, which I assume people are familiar with, a transaction is 540 bytes long. Okay? And then a block is mined every 10 minutes. Okay? The block size is set to 1 megabyte, and hence we have that the throughput of Bitcoin is determined by this particular factor, 1 megabyte every 10 minutes. If you now take this 1 megabyte and divide by these 540 bytes, we end up with roughly 1900 transactions. Okay? And here we have 19 transactions every 10 minutes. If we now move minutes to seconds, you'll have to divide 1900 with 600 seconds, and this gives you roughly 3 transactions per second. Okay? This is where this magic throughput limit comes into play. Okay? And so, but just looking at this very simple, these few simple numbers here on this particular slide, you can easily get an idea on how we might be able to make this much better. Okay, this particular thing, 1 megabyte every 10 minutes, is the bottleneck. Okay, if we can increase thus the amount of the block size or decrease the interblock time, we should be able to significantly increase the scalability of a blockchain system. So why don't we do that? I mean, I'm tossing up idea, maybe we now just resolve the biggest problem of blockchains and we all go happily home, everybody happy, we accomplished something, and I can end right here. The trouble is, you might be able to keep increasing this, but at some point there must be some limit that just you can't go over. And people did, what I'm talking about, people actually tried. There's one famous example where people tried to push this to a bigger limit, and they increased the block size to 30 megabytes, but eventually one block was mined after 20 minutes. A block was mined, and then it ended up reaching the rest of the miners after 20 minutes. And the whole world was like, hey, how could this be? It's 21st century, the internet is so fast. What's going on with the world? Why do we take 30 megabytes for something to propagate around the world? Okay? And so this is where our expertise comes into play. I teach computer networks at Northwestern, and I can tell you that there's 1,000 reasons why things can go wrong on the internet. And I'll just show a few scenarios, and then we can take it from there. So consider a miner on the left. Somebody was just lucky enough, they just mined a block, and they want to send this to their neighbors. In the real world, typically there's 8+ neighbors. I'm here drawing just 3 of them, because the slide would be more busy if I had eight neighbors, okay? So I'm just showing 3. But then, each of these, for example, this guy could be in Europe, while another miner could be in China, the other guy could be in the US. To send this block from a single miner to another miner, that block has to go through a number of different independent networks, okay? If somebody is watching Netflix somewhere on the internet, then this part might be utilized, and the fact that somebody is watching Netflix can affect the time it takes to propagate this block between 2 sites in the world. This is what the internet is. Okay, and so just on this, if you consider here, consider 10 networks between any two nodes, and consider 10 peers. 10 times 10 it equals 100. Okay, so we already have 100 places. If things go wrong in one of those places, there's going to be trouble propagating things. But this, unfortunately, is just the beginning of the problems, because in the peer-to-peer system, this is just the first hop. After the first hop, all of these miners have to send to their own neighbors. Okay, so this thing is growing away, and the number of places where things go wrong is increasing exponentially. Moreover, not only do we depend on what the ISPs are doing or not doing, but we actually depend on the hardware of other miners. If you are peering with some miner who didn't do the job well and has malfunctioning machine, well, I'm sorry, the fact that you just mined a block, that block might have trouble reaching the rest of the world simply because you are dependent on what everybody else is doing. So this brings me to explaining what is it that we are doing here in this particular space. And so what we have designed is a thing called a blockchain distribution network. Blockchain distribution network is similar to content distribution network, but given that we are dealing this blockchain space, we call it the blockchain distribution network. It is a global network that helps propagate transactions and blocks much faster and is capable of pushing the scalability of any existing blockchain. So to explain how it works, let me go back to the example of sending that 30 megabyte block that one of the blockchains had trouble transmitting to the internet. So basically, what is happening within our network, these red dots are supposed to impress you because there's been a lot of work on this slide. But basically what this is showing is that BloXroute, we are not only propagating blocks through the system, we are propagating transactions, so our network is aware of every single transaction that appears in the blockchain system. Because we know what the transactions are, what we are doing, each of these transactions, we are locally indexing them and assigning them 4-byte identifiers. These are much shorter identifiers that are uniquely associated with each and every transaction. Why is this important? This is important because once the block comes into play and once a miner mines a block consists of transactions, and given that these transactions are already distributed within our network, it is possible for us to significantly reduce the size of that block within our system. How are we doing that? Well, instead of using the original transaction of 540 bytes, we use the short version, which is only 4 bytes long. And hence, if you have a 30 megabyte block, in our world this becomes 222 kilobytes. So instead of sending a large, huge file, you have to send a tiny web page. I mean, this is the analogy. Another place where we are innovating and where we are making sure that this thing is happening quickly is a thing called cut-through routing. So what we are doing is basically, this is a fairly known technique in network switches, but we are the first to utilize this in the context of blockchains. And basically what this is doing is, here you have the same miner on the left side, and this particular axis is showing time. Okay? So what happens here is that our block is being mined by this guy, and then it takes some time just to push this, to put this particular block on the Y. Okay, then there is a propagation. It takes a little bit of time that this block actually reaches our server, but the new thing here is that you can see that as soon as the first bits of this particular block are received by our server, this particular service immediately starts sending this to the rest of the network. Okay, before it receives the entire data. Because it's not checking whether data is valid, it's not doing any of that, it's just trying to optimize for performance. Okay? And so what can happen here is that this guy still didn't finish sending the entire block, it still has a few bits to send. On the other part of the world, this guy already started receiving the block. So we are effectively doing a lot of streaming and optimization so that we can actually make sure that we can gain even more performance improvements relative to what's happening otherwise. So to summarize, instead of having 1,000 places where things can go wrong, we simplify the system significantly. Basically, here we have 3 links between any 2 endpoints. So first, the blocks themselves are much shorter because we are using these optimization techniques. We are using identifiers. The second important thing is that instead of having 1,000 different locations where things can go wrong, here we have a single access point which is very close by to a server. We optimize things within our network, and then you have the third link, which is from these servers to all other endpoints. And one very important issue here, and a very important thing, is that contrary to the original case in which you depend on what others are doing, on other miners' infrastructure and hardware, here it's not the case. Because here we have a broadcast layer that sends information directly from every single miner to every other. They are all directly connected to each other. Okay? Which helps significantly with decentralization because now it doesn't matter who is who, but everybody is connected directly to everybody else. So, an important thing that we are doing basically, I'm from academia, and in academia we tend to do a little work and then show a lot of results. We want to claim everything can be done, but in reality that's not as so. So it took us a while to go from the idea to actually showing that we can actually do these things. It took us 1 year to come to this result, which is we took the Bitcoin code and we ran that on top of BloXroute, and we were capable of pushing that to more than 1,000 BPS. This was a huge result for us because doing this is not easy, but doing the things that I explained that we're doing, we were capable of doing this. So to give you more ideas, so we had more than 300 nodes, we had around 30 miners all over the world, and we were capable of pushing between 50 and 100 megabytes every minute. And so this now is a very important part of our solution. So to summarize what we have done so far, basically what I just told you about is that if you have a very good network, well-provisioned network, optimized network, you can scale blockchains, okay? But this shouldn't come as a surprise because, I mean, you have YouTube. YouTube is pushing a gigabyte of data every single second and nobody blinks an eye. Everybody's like, sure, that's how things should work. It's 21st century, the internet is fast, right? So it's not a surprise that we can actually scale up networks that have 1,000 to 10,000 to even 100,000 nodes, okay? The real contribution of what we are doing is that once you add such a powerful network in the middle of blockchains, the key idea behind blockchains is these are distributed systems that nobody owns, everybody runs their own code, and hence nobody can sense or do anything wrong with the system. The system is resilient, and there is no single player that can turn down the system, until, okay? And so once you bring in this very powerful network in the middle, well, we are creating a very powerful player, right? So the key idea behind BloXroute from the very beginning, because we were aware of this issue, we said, you know what? We're going to design a network that is provably neutral. That means the network that that even the administrator of the network cannot censor transactions and cannot favor one traffic over the other unless it's known to everybody in the system. Okay? And so this is the PhD thesis of my former PhD student, Uri Plan, who is now happens to be our CEO. And so basically, I'll just very quickly give you just a flavor of what this looks like. Other than that, this is really my, this is what I do for living otherwise, because net neutrality is something that I'm working on for over 10 years, and basically, but I'm not going to dive into details. So basically, if I would have to explain this in simple terms, it would be, assume somebody comes to us, some authority comes to us, and say, and tell us, listen, this particular transaction we are sure belongs to some very bad people, doing some very bad things, like gun smuggling, whatever. Okay? Whenever you see this transaction, please let us know, or don't let it run through your network, because this will cause harm to the world and it's not good for the world. Okay? Our answer to any such request is, dear whoever, we sympathize with your problems and we will be happy to help, but there's absolutely nothing we can do to help serve your request, simply because we are incapable by design of censoring anything going through our network. Okay? How is it possible? Where all the blocks coming to our network are encrypted. Okay? What that means is that the gateway, which is part of our system, the endpoint, before it sends any block, it encrypts the block. So once it comes to us, we don't see what's inside. We have to serve all of those. Okay? Only after the blocks reach the endpoints, they exchange the keys, and it becomes possible for the endpoints to realize what actually was in that particular block. And we have other components which I'm not going to go into, and so on. Another important issue is development is great, but how do we deploy this to the real world? Okay? Somebody who just got showered with this. Okay? We are working with the mining pools of the world, okay? And we are giving them for free our gateways, okay? And currently we are, of course we had these experiments with the Bitcoin Cash community, and we basically are collaborating already with the leading mining pools of the world. How do we do that? Well, we simply provide them our open source gateways. They just put this on their machines and it works. So far this looks almost perfect. Something must be wrong, right? Because if it works great and it's free for everybody, like who is paying, how does this work in the first place? So basically, I will quickly just go through our business model. It's the end users who benefit the most from our system are the ones who are paying the tiny fee to the BloXroute network. How does this happen? Well, the users are the main beneficiary of this particular system, okay? And in a scenario in which we can bring up the scale of a blockchain to more than 1000x, there is a plenty of value that can be distributed among all these players. Okay, so the end users, they get 100 times smaller fees, the miners themselves get 10 times more fees, and it's still possible for us to make money and to make the whole system sustainable. Not just sustainable, but there is a huge amount of money that can be, that this network can actually make. Despite the fact that we are not a blockchain, that doesn't mean that we don't have our own token. And our system is very simple. We have our token is a security token. It has been from the very beginning. We never played any games of trying to have utility or something like that. And it's a very, very simple dividend type of model, okay, where there is a finite amount of BLXR tokens, so whichever percentage of tokens you have, that much you get access to revenues. To the revenues that I explained on the previous slide. So it's a very, very simple, straightforward dividend model. Long story short, currently what we are doing is we are doing testing with Ethereum community, with the Ethereum network on the mainnet. We are working with the leading mining pools of Ethereum, and we are currently, as I speak, we are doing this test, and we are hopeful that we will be able to scale Ethereum and give scale to their network. And of course, we are talking to many other projects. If you're a blockchain system and want to talk to us, we are more than happy to work with you. In summary, so we are trying to help all blockchains to scale, and this is what we are going to do. That said, I thank you for your attention, and thanks so much.